Before we get started for today, what I'm going to do is connect our exponential and our knowledge of exponential functions with the logarithms. So first off, you guys do not have what you see here in your notes, but if you kind of refresh our properties of powers and our properties of exponents, whenever you multiply, you are adding your exponents. So for example, this first one, x to the third times x to the fourth, you would just add our exponents to get x to the seventh. For the same concept, but a little bit different in terms of our operations, when you divide, you are subtracting your exponents. So for example, this one would be x to the fourth because 6 minus 2 is 4. So the reason I'm introducing that is because those exponents and the properties of those exponents are directly connected with our properties of logarithms because we have inverse functions. So as you look here, your product rule, if you are multiplying your bases, or excuse me, multiplying your logarithms, you are essentially splitting it by adding. If you are looking at division here, you are splitting it and using subtraction. This power rule, what you're doing with this is you're taking the power out in front, which is going to give you the result of c times log base b of r. So again, the key is if you have multiplication going on in the parentheses and it's asking you to expand it, you're adding. You have division, and you're asked to expand it, you're subtracting. Okay, so let's take a look at some examples. Notice here it says prove the product rule for logarithms. So here's what you would do. You would say, okay, I'm going to let x equal log base b of r, and you would also let y equal log base b of s. And so what you're going to do is you're going to rewrite that as an exponential. So we're going to just change the form, so the b is going to slide underneath this and become b to the x equals r, whereas this one will become b to the y equals s. So all we are doing at that step is rewriting. Now we know that if we multiply r times s, because we're looking at the product rule, r times s is the same as b to the x times b to the y, because we're just substituting. We know r is b to the x, we know s is b to the y. Then we use our properties of exponents that rs on the left would equal b to the x plus y. Again, we're using those property of exponents. When you multiply, you add your exponents. What you're then going to do is you're going to then rewrite back into logarithmic functions. So we're going to rewrite this again, going back to logs. So it's going to be log, the base is b, because that's the base of your exponent, of rs equals x plus y. And then for your final step, you are then substituting back in from the very beginning. So log base b of rs equals our x from the beginning was log base b of r, and you have log base b of s for what your y equals, coming from that very first step. So by doing some rewriting and going to the exponential form in between and using our properties of exponents, we can then go back to the logs at the very end and prove that product rule. So let's go ahead and do some application of it. So if you look at this, notice it says that we are going to expand the expression. So what we have going on here is that 9 and y is separated by multiplication. So to expand it, it's going to be natural log of natural log of 9 plus natural log of y. The next thing that you could do is you could take it one step further, and 9 is 3 to the second power. And then I can take this 2 out in front, so we could have a final answer of 2 times the natural log of 3 plus natural log of y. Right? That is our answer fully expanded. If we take a look at the second one, this one is pretty straightforward because there's no multiplication or anything going on, but we do have an exponent that we can slide out in front. So it's just negative 2 log base 2 of x. That's it. We don't have any sort of multiplication or division where we can expand that any further. Now, part C has several different things going on. If you take a look at this, and we can go ahead and split this, so we have log of 1,000 plus log of x to the 4th. Now, log of 1,000 simplifies to just be 3. Okay, that just simplifies to be 3 because this is really log base 10 of 10 to the 3rd power, and so the log base 10 and the base of 10 cancel, so that's where the 3 comes from. Then we can take that exponent of 4 and move it out in front, And so we have 3 plus 4 times log x. And that's it. All right, next one, if we look at part D, notice we have division going on here. So you can have the natural log of the cube root of x minus the natural log of the cube root of y. Now, if we look at this, we can think about this, and if you want to, you can take this middle step. The cube power, or excuse me, the cube root is the same as the 1/3 power. And so we can then take that 1/3 exponent and move it out in front to make the 1/3 natural log of x minus 1/3 natural log of y. And again, because we are expanding it, we want to make it bigger, not condensing it, making it smaller. Now notice, if we look at the next set, we are now going to write it as a single logarithm. So we're going the opposite direction. We are condensing this. So since we have a plus sign here, that tells us when we condense it that the x and the 5 are going to be multiplied together. So we have log of 5x. For the next one, since you have a 1/5 out in front, we are going to then take that to the exponent. And so again, you can have log, and then we have z to the 1/5, and we can go ahead and make that 1/5 power a 5th root. And that's going to be our answer for that one. Part C is a little bit more complicated. We have several different things going on. So we're going to do order of operations first, and we are going to take this cube up here, we're going to take this squared up here. So at this point, we have natural log of x to the 3rd times y to the 3rd power plus natural log of yz squared to the 2nd power. Now, if we do our properties of exponents, when we take a power into a power, we are multiplying. And so at this step, we've got the natural log of x to the 9th, y to the 3rd, plus natural log of y squared z to the 4th. And then, because we have addition separating these two logarithms, or these two natural logs, we are going to go ahead and multiply these pieces here. So we have the natural log, x to the 9th doesn't have anything to combine with, y cubed and y squared, because we are multiplying them, we are going to add our exponents to get y to the 5th, and then we have z to the 4th, and that is our final answer. Okay, moving on. This is using your calculator. There's what's called the change of base formula. Basically what you are doing is most calculators, unless you have some of the scientific calculators with the newer programming, they don't have any bases except for base 10, which is log, or the natural log, which is just base e. Those are the most common buttons that you guys will see on this regular scientific calculator. So what this does is this opens the door for you to be able to use those types of calculators in when you're evaluating logarithms. The reason you have to do that is if you think about rewriting this as an exponent, so like 5 to the x equals 19, we don't really know what that answer is going to be, because you can't just say, well, it's going to be 5 squared, or because that's 25, or 5 to the 1st. This number falls in between there. So what you are entering in your calculator, because you can't just do this in your head, is you're doing log 19 divided by, and then the base of 5 goes on the bottom. So I always remember base bottom. And you're typing this in. Just make sure that you use parentheses. So your calculator will input a parenthesis here. You need to make sure you close it off. Okay? And so log 19 over log 5 gives you approximately 1.83, which makes sense because 5 to the 1st gives you 5. 5 squared gives you 25, so you know that your answer has to fall between 1 and 2. Okay, the same thing goes here. 12 to any power doesn't equal 259 as far as a whole power, so we can then use our change of base formula. Again, you can use log or natural log, so let's just go ahead and use natural log just to get us used to it. 259, and then the base is 12, and so when we type this in our calculator, we get approximately 2.24 for an answer. Okay? So again, that's just knowing how to use your calculator. The TI-84s, some of the newer programming will allow for you to have a different base, as does the TI-Inspire. So some of these will allow for you to enter a different base. This opens the door for you to use any calculator to evaluate your logarithms. Okay, moving on to this last example. The Richter scale magnitude R of an earthquake is based on the features and is measured by, and then it gives you this formula. Okay, gives you this formula where A is the amplitude, T is the period, B accounts for the weakening of the seismic wave due to distance. So the closer you are to the epicenter, the stronger it is. The further you are, the weaker it is. and you're supposed to calculate the earthquake's magnitude. So basically what you are doing is you are just reading and you are substituting where it is applicable. So we're using our formula. We need to find the magnitude R. Our A is 250. So again, we're using this formula in our word problem. So we've got log of 250 over T. Our T is 2 plus, and our V is 4.25. And so then we are just typing that in our calculator and evaluating. And so with all of those pieces of information, we have a magnitude of 6.347. Okay. Now, if we look at the second one, again, all we are doing is plugging in our information. So again, we've got log, our A is 300, our T, again, which is the period in seconds, is 4, and then your V, so the distance away from the epicenter, is 3.5. Type that all in, and you get 5.375 for a magnitude there. So again, all this one is just reading your information and making sure that you substitute in where it is applicable. Okay. So the big things today is making sure that you know how to condense and expand your logarithms. So this example, and then also this example, and then last but not least, making sure that you know how to evaluate your logarithms. Okay. As always, ask questions if you got them. Hopefully that is all pretty straightforward. Have a great one.